Hello everyone. Today we are going to talk about TF-IDF. TF-IDF is a numerical statistic used to analyze text documents for important words. TF stands for term frequency and IDF stands for inverse document frequency. You want to find important words in a document to figure out what words identify a piece of text. For example, if you listen to speeches of President Obama, you will find the word healthcare repeated many times because in his speeches it has a specific significance. Similarly, if you go through speeches of Martin Luther King, you will see that the word dream is used in a special context. So this word identifies his speeches. If you can cluster documents based on the words, then you can use it in different applications. For example, if a user searches for a document, you can show them related documents from a set of similar documents. Let's start with a simple example. First, look into term frequency. The sentence we are going to look at is "The cat is on the mat." We will find out how many times each word occurs in the sentence. We can see that the word "the" is repeated 2 times while the rest of the words are repeated only once. The next example is a sentence, "The dog is in the fog." Again here the word "the" is repeated twice while the rest of the words "dog is in fog" occurs only once. Our third example is "The cat and the dog are friends." Here the word "the" is repeated twice while the rest of the words are repeated only once. Now let's see how we can calculate term frequency. Let's calculate term frequencies for these 3 sentences. The first sentence, we can see that the word "the" is repeated 2 times and the total number of words in the sentence is 6. So we just divide 2 by 6 and we get term frequency as 0.33. Now we do it for the second sentence, and since the number of words is same in the second sentence, the term frequency of the word "the" is same because it is repeated there also 2 times. Now in the third sentence we have more words, so instead of 2 divided by 6 we are doing 2 divided by 7. The term frequency is slightly lower. Again, let's move on to the word "cat." It has a lower frequency because it appears only once in the first sentence, so we divide 1 by the total number of words, which is 6, and we get a term frequency of 0.17. Second sentence does not have cat in it, so the term frequency is 0 for the word "cat." And in the third sentence we have cat appearing once and the total number of words is 7, so the term frequency is 0.14. Similarly, we can just divide the given word by the total number of words in that sentence and calculate term frequency. For the last word, we see that it appears only in the second sentence, so the term frequency for the second sentence is 0.17, while for the first and the last sentence it is 0. So term frequency is simply a ratio of that word occurring n number of times divided by total number of words in that sentence. Now you can see that if you use only term frequency to find the importance or significance of a word, it is not enough because it is just going to find out how many times a word is occurring or what is the frequency in the given document. So if you just go by the occurrence of words in a sentence, then articles like "a" and "the" they will have a very high ratio, and usually they don't carry a specific meaning in terms of importance. For that, we have to bring in another term which is called inverse document frequency. Inverse document frequency tries to find out words which are unique to a document, and that is done by doing a ratio of total number of documents and dividing it by the number of documents that actually contain a certain word. So you can see that if you will pick words like "a" and "the", they will be appearing in all the documents, so the ratio of total number of documents divided by the numbers of documents that have those words will always be same. So in this example, our three sentences, they all have the word the, so the ratio is 3 divided by 3, and the log of this ratio is going to be 0. So in this case, those words which are appearing in only a smaller set of documents, for them the value of log and this ratio will be higher than 0. This will bring up those words which are unique to certain documents. This essentially will give a higher score to those words which are unique to just one document or maybe two documents. Now let's put these two metrics, term frequency and inverse document frequency, together and observe how they are basically showing up for each word in this chart. We can see that the term frequency for word the is higher, but the inverse document frequency is 0, making the effective product as 0. But for the word cat, the term frequency not as high, but is still the inverse document frequency is more than 0, so the product will give a value more than 0. And those words which are the last in the list, the mat and fog, because they are unique to just one document, their inverse document frequency is much higher, and therefore when they multiplied with the term frequency, the product is even higher. When these two terms are multiplied, we will see them in the next slide. Here you can see that the colored cells are basically showing those documents and the word combination where the product is more than 0. This way you can see that the word cat is important for first and the third document because it appears in those two documents, but since it does not appear in the second document, so the term frequency IDF, inverse document frequency, the product is 0. Similarly, the word dog is important for documents 2 and 3, and the word mat is important only for the first document. This way we have removed those words which don't contribute towards the importance within the document. So only words which are unique to a document actually contribute towards the importance. As we know that we were using log function for inverse document frequency, so let's see what are the characteristics of a logarithmic function. In the numerator we were putting the total number of documents, and as the number of documents will increase, the value of logarithmic function will not be linear, it will be increasing but at a consistent rate. It means it will not grow exponentially. So as the number of documents increases, your inverse document frequency score will increase at a consistent rate. As far as the denominator goes, if the number of documents which contain the word increase, it will keep the value of IDF relatively lower. But if the number of documents is very little, it will cause the inverse document frequency value to be relatively higher, and that will contribute towards making the word important for that given document. So we will wrap it here by looking at this matrix where for every document and corresponding word we have scores, and a higher score indicates that that word is important for that document. When we actually use scikit library to create this matrix, we can leverage it to find important words, and with using those important words and the relationship with the document, we will be able to cluster them in a group.